Okay, I'm going to go through this one, our last lesson for tonight. I'm going to go through it pretty quick, and this is very, very focused on Math 053. If you're not in Math 053, I would not worry about this yet at all. But if you are in Math 053, this is the kind of stuff you are definitely going to have to do in Chapter 3. So on Monday, we talked about equations that have brackets in them. No big deal. We first expand the brackets, then we do exactly what we would have done otherwise. And yeah, just making sure I unmuted myself, sorry. And also, we learned how to deal with equations that have fractions in them. We figure out the lowest common denominator, and we use that to make all the fractions go away, and then solve as normal. So, if an equation has both brackets and fractions, there's actually one of two ways you can do it. You can either expand the brackets first, then clear the fractions, which that is going to be, for most people, that makes more sense. And it's hard to get into exactly why that is. You can clear the fractions first and then expand the brackets. And that is often going to be a bit faster, but it also leads to a lot of confusion and errors because people try to, when they clear the fractions, they try to multiply too many things by the common denominator instead of just the things that should be multiplied. So for now, I'm going to stick with just the first method because most people see it, it makes sense, and they can do it reliably without accidentally over multiplying the denominator. If you want to see the other method during our question time, I'm happy to show you one with the other method just so you can see how it works. So if we see this example here, we see we got fractions, and I don't like fractions, but I also see I got some brackets there. And so we've decided to stick to the approach that makes the most sense for most people, and that is we are going to first expand the brackets, then we're going to deal with the fractions. So 7/10 times, so that blue minus sign is going to stay a minus sign, right? And the 7/10 is going to multiply by both of the things in the bracket. So there's that minus sign on either side of it. We put the 7/10 times x and the 7/10 times 3. That's how we expand that bracket. And the rest of the equation all just sits there while we do that and doesn't change. So let's look at this now. We got, let's clean this up a little bit. Anything that has to multiply by a fraction, we need to make over 1. So that x has to be x over 1, and 3 has to become 3 over 1, like so. Because now we can just multiply tops and multiply bottoms. 7x on the top, 10 on the bottom. The minus sign still there. 7 times 3 is 21 on the top. 10 times 1 is 10 on the bottom. Plus 2 equals 4/15. None of that changes. Okay, now we've dealt with the brackets. Now we can proceed with what we did on Monday, which was to clear out those fractions. So this is a good little reminder of what we did Monday. So what we need to start is the lowest common multiple between 10 and 15. Well, I would say on this one, I would just list off the multiples of 15 until I see something that ends in a 0, because I know anything that 10 goes into has to end in a 0. And there it is, 30. So 30 is the smallest number that 10 and 15 both go into. So I am going to take that 30 and I am going to multiply both sides by 30, because that's how I make fractions go away. I multiply both sides by the lowest common denominator. That 30 is going to have to go into that bracket on the left. So we have 30 times the first piece, 7x over 10, minus 30 times the second piece, 21 over 10, plus 30 times 2, and over there on the right. If we chose that 30 properly, once we've done a little bit of canceling here, we should have no fractions left. So let's try it out. Anywhere where there's going to be fraction work, the 30 needs to become a 30 over 1. So that first term, it's going to have to become 30 over 1, and this term and the last term, but this one right here is just 30 times 2. I'm not going to turn that into fraction work for no reason, right? So The 30 becomes 30 over 1 wherever I want to swipe out fractions. And again, if I chose my numbers right, I should be able to start crossing everything off. Oh yeah, little note, I do a lot of steps here just so you can really see what I'm doing. I think you'll find if you look carefully there, you can probably skip right to that step. You can probably go right from here and say, okay, lowest common multiple is 30. I'm going to go 30 over 1 because that's a fraction, 30 over 1 times that one because that's a fraction. Oh, just 30 because it's a whole number, and 30 over 1 because it's a fraction, and skip right through that, writing 30 times the whole left side and the whole right side if you want to. Okay, now we're going to start to cancel things out. So we want to make all the denominators 1. If we pick the 30 correctly, that should happen. 30 and 10 cancel because both divide by 10. Leaving 3 over 1. 30 over 10, again, leaves 3 over 1. And again, if you've done your job right, the bottoms are always 1, so really you're just dividing here if you want. 30 divided by 10 is 3. 30 divided by 10 is 3. 30 divided by 15 is 2, or in other words, cancels to 2 over 1. Okay, looks like we succeeded. All of the bottoms are now 1, so all we have left is tops. 3 times 7 times x is 21x. Then there's a minus sign. 3 times 21 is 63. Then a plus sign. 3 times 20 is 60. Equals 2 times 4 is 8. There we go. It's a bit of a hassle, but trust me, it's way less work than trying to actually move all the pieces around with the fractions still in them. Going to decimals doesn't help if you're tempted to do that and use our decimal trick, because these are not all nice terminating decimals. 4/15 is a decimal that repeats, and anytime you cut off a decimal before it gets to its end, you get a rounding error in your answer. You get the wrong answer. Okay, so let's take this. I'm going to shift everything over to the left there. I'm going to move that equation. Oh, no, I'm just going to keep working. So I notice a minus 63 and a plus 60. I would be inclined to combine those together first. You could also move them both to the right, plus 63 and minus 60, but I would be more inclined to do that. A subtracted 63 and a added 60 means 63 to the left and 60 to the right. So you subtract them, you went further left than right, so it's minus 3. We take that minus 3 on the left and we make it a plus 3 on the right. 8 plus 3 is 11. And we divide both sides by 21. And the 21s cancel. Notice I'm not going to turn this into a decimal. The only time we give decimal answers is when they specifically instruct us to, or I would say if the question has decimals, you are fair game to put your answer to a decimal usually. But if there's no indication of decimals and they don't tell you to give a decimal answer, we always keep our answers as fractions. Okay. I'll let you stare at that or screenshot or anything, and if there's questions afterwards, I'm happy to answer them. Oh yeah, so we're going to get you to try one. So see if you can give this a shot. Just get as far as you can. Start by expanding that bracket, multiply the 2/3 through the bracket, figure out the lowest common multiple, see how far you can get on that, and we'll give you 3 or 4 minutes for that. Okay, so here we go. We have fractions and brackets where we've decided whether or not it's the fastest method, it's the surest and the least easy to do something wrong method, is to multiply that 2/3 through the bracket. So I didn't do my little squiggly lines this time. 2/3 times 2h. The blue minus sign stays the blue minus sign. And 2/3 times 4. So that's that 2/3 distributed through the bracket. Everything else just stays as it is. And now before I can go anywhere, I got to get these into single fractions. So 2h becomes 2h over 1, 4 becomes 4 over 1. You could clearly have done that if you're writing this out on paper. You could have done that in the same step, right? Just notice the things that have to be over 1, or even just do it afterwards, just do a little over 1 after the fact. The tops multiply, so 2 times 2 times h. 2 times 2 is 4, so that's 4h. The bottom is 3 times 1. 2 times 4 on the top, 3 times 1 on the bottom, 8 over 3. And the rest stays the same. Okay, so now I've dealt with the brackets. Next, I have to deal with the fractions. I want the lowest common denominator. So the lowest common multiple of 3 and 9. Well, 3 goes into 9, right? So 9 is the LCM because both of them go into 9. So I'm going to multiply both sides of that equation by 9, like so. And on the left side, I know that 9 has to distribute through the bracket. So 9 times the first term, 9 times the second term, and 9 times the third term with the minus and the plus in between, just as they are. Wherever I am going to have to do fraction reducing, that 9 needs to become a 9 over 1. But wherever I don't have to do fraction work, like this term here, I'm just going to leave it as a 9. And now, if I've done my job right, all of my denominators should cancel. And look at, they do. 9 over 3 reduces to 3. 9 over 3 reduces to 3. 9 over 9 reduces to 1. Let's do that one at a time. Of course, when I say reduces to 3, it's 3 over 1, but we don't need to say the over 1, right? So like so. All of the bottoms become 1, which is exactly what we wanted, so there are no fractions left. What are these remaining terms? 3 times 4 times h is 12h. Then there's a minus sign. What's left here? 3 times 8, 24. Then there's a plus sign. 9 times 1 is just 9, equals. And what's left here? 1 times 5, like so. So a little bit of work, but we dealt with the brackets. We dealt with the fractions. I'm going to shift that all over. Now we just have a nice old equation. Again, I would notice the minus 24 subtracted 24 and added 9. You could make that added 24 and subtracted 9 on the right, or you could first combine them, which is what I'm going to do here. Minus 24 plus 9 is minus 15. That's 24 to the left and 9 to the right, right? So remember, if they go in opposite directions, we subtract. 24 minus 9 is 15. And then you look at which direction you went further. I went further to the left than I did to the right. That subtracted 15 on the left becomes an added 15 on the right. 5 plus 15 becomes 20. Divide both sides by 12 because it cancels on the left and leaving just h. And we get 20 over 12. Well, that's not good. We got to reduce that. Top and bottom can both be divided by 4. So the answer is 5 over 3, or if they want a mixed number, 1 2/3. All right, is that the last one? Yep, that is my last slide. If you want to talk about the clearing the fractions method first, that would be up here. Instead of starting by expanding the brackets, you would start by multiplying by 9. The trick is on this piece right here that I've sort of highlighted there. Didn't work very well. Maybe I can box it. No, I can't. Okay, on that piece right there, you would only multiply it by the fraction. You would not, people are tempted to multiply the 2h and the 4 by the 9 if they clear the fractions first, but you would only multiply it by the thing out front, because later, when you expand the brackets, that 9 you multiplied by will automatically go through the whole bracket. And that's where people get really confused if they try to clear the fractions first. It is, I think, a little bit less work to clear the fractions first, but if you're at all uncertain about that, like I said, you would just multiply the 9 by this piece, and by the 2/3 out front, not by all the things through the bracket. You wait for the distribution to happen before you do that, and that happens automatically. Again, I can show you one like that if you want, but I find this method most students are able to lock into and be successful with without accidentally over multiplying the denominator.